So we're going to start from scratch here. And we always start from a right angle triangle. So when we say right angle trigonometry, we mean dealing with triangles with a right angle somewhere. So of course this little box means 90 degrees, right angle. For the right triangle shown, so we just abbreviate there. Just draw a triangle instead of saying the word triangle. Save a bit of time. Evaluate the three trigonometric ratios for the angle theta shown. So what's this little symbol here that looks like an Easter egg? That is a Greek letter, theta. Sorry, I'm Australian, so I say theta. I think in America, in the North Americas, they say theta. Okay, but you're going to hear me say theta, so you'll have to get used to that. And there are three of these ratios. Now, what are the three ratios? That is a sine, cos, and tan we're talking about. So let's just summarize them before we answer the question. Sine is this. The sine ratio is SI, and we just say sine theta equals, and what that is the opposite over the hypotenuse. And what do I mean by that? Well, I mean, if this is the angle theta, then we have ways to describe the three sides of the triangle. This is always the hypotenuse. It's always the longest side in the right triangle. It's always opposite the right angle. And then you've also got an opposite side. This one's the opposite. And this one here is called the adjacent. Kind of like the next door neighbor of theta that is not the hypotenuse. So just be careful that that's when we're talking about the angle theta. If I had another angle down here called angle x, then the hypotenuse stays the same. But the adjacent and the opposite will swap. So if we're talking about the angle x here, then that means this is going to be the opposite, and then this is going to be the adjacent. Okay, so I'm just going to leave that there, because that's what really confused me when I was in grade 10 learning this. What is cosine? Cosine is cos theta, if we're talking about the angle theta, and that is the adjacent divided by the hypotenuse. Okay, so you see they are called ratios because we're just dividing two numbers. It's just one number divided by another number. That is what the cosine ratio is. So in this case, sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. And the last one is the tangent. We just abbreviate that to tan, T-A-N, theta. And tan theta is opposite over adjacent. So they are the three basic trigonometric ratios. Or we could just abbreviate that to trig ratios if you like. And there's a way to remember these. Sine is always opposite over hypotenuse. So remember SOH. SOH. Cosine is adjacent over hypotenuse. CAH. And tan is opposite over adjacent. TOH. So you can say this soh-cah-toa. That's how you can remember that. Soh-cah-toa. Right? You'll see that in textbooks usually. So that's kind of like your notes, everyone. Okay, now we're actually going to do the question. So sine theta in this case is sine theta equals opposite over hypotenuse, 3 over 7. 3 over 7. Now the actual answer we're looking for here is that. Don't say sine equals 3 over 7. This is kind of like mathematical grammar here. You have to say sine with an angle equals 3 over 7. Now that's not sine times theta. This is sine theta. So it's kind of like f of theta. Okay, it's like a function. Sine is like a function of theta. Cosine. And by the way, if I was doing sine x, what would that be? Sine x would be this divided by this. So if it's sine theta, it's that divided by that. But if it was sine x, that would be that divided by that. Cosine the sine, cos theta. Cos theta. So I would like to see the equation, but the actual answer is in the box there. Cos theta is adjacent over hypotenuse. But what's this? We don't know what that is. How are we going to get it? Well, we have a right triangle, and we have two sides, but we don't have the third side. So we can use Pythagoras here. So I won't call that x because I already used x. I'll say that's y. Pythagoras. Y squared plus 3 squared equals 7 squared. This is from geometry coming back. 9 equals 49. Y squared equals 40. So y is going to be plus minus root 40. But we're dealing with a length, so we don't need the plus or minus. Y is just going to be some positive value. Can that simplify to something root something? Yes, it can. That is 2 root 10. Should not be a problem for you. So y is 2 root 10. We now know what this length is. Here is. So let's do cos theta. So that is adjacent 2 root 10 over 7. We don't like radicals on the bottom of our final answers. Okay, that golden rule still holds true. Tan theta. Tan theta is opposite over adjacent. So this is 3 over 2 root 10. 3 over 2 root 10. There we go, but we break the golden rule there. We have a radical on the bottom. We don't like that. Radical 10 on the bottom. I'm just going to multiply top and bottom by radical 10. That should do it. Normally I would go down the page, but I'm running out of space here, so I'm just going to go across. What do we get? 3 root 10 on top, which is just 3 root 10. That does not simplify. On the bottom I have 2 times root 10 times root 10. Root 10 times root 10 is 10, times 2 is 20, and that is the right answer there. Same, 3 over 2 root 10 is the same as that, but we don't like radicals on the bottom. Okay, so they are the 3 trig ratios, sine, cosine, and tangent, soh-cah-toa, for a right triangle.